to 10 and 11 square is equal to 121 is greater than 113. So we only need to check primes less than 10. 113 by 2 equals 56 into 5. 113 by 3 is similarly equal to approximately equal to 36.67. 113 by 5 is approximately equal to 22 by 0.6. 113 by 7 is approximately equal to 16.14. Since there are no more primes less than 10, and we are done and conclude that n is equal to 113 is prime. Here we can simply use this concept to prove the number is prime. Like here again we are discussing 113 is prime, and to prove this we are just taking the square root of 113. So square root of 113 is near about greater than equal to square root of 100, and which is equal to 10, and 11 square is equal to 121, which is greater than 113. So this must be greater than 100 and less than 113. So we only need to check the primes less than 10. So here by using this there are no more primes less than 10. So here we can conclude that n is equal to 113 is prime. We can also use this to compute prime factorization of composite numbers. Like if we are taking a number 1617, then if 1617 is divided by 2, it gives 1808.5. Same by 3 equals 539. 539. Same here, 539 by 2 is equal to 269.5, and 539 by 3 is approximately equal to 179.67, and same 539 by 5 equals 107.8, and 539 by 7 is equal to 77, and 77 by 7 equals 11, and 11 is prime. So we can use this number, and here if we factorize this in the form of prime factors, then 1617 having the factors 3, 7 and 11, but here 7 is 11, 3 into 7 square into 11. So this is in product form, and 3, 7, 11 are the prime numbers. For each of the following, we use the trial division to determine if they are prime. If they are composite, then find the prime factorization. Like n equals 29, n equals 97, and n equals 143. Note that to do trial division we needed list of prime numbers. Finding lists of the prime numbers is usually done with a sieve. This theorem we have already discussed in the earlier lecture series. The prime sieves works by creating a list of all integers up to the desired limit and progressively removing composite numbers until only prime numbers are left. We will look at the simplest prime sieves, the sieve of Eratosthenes. Note that this point we have already discussed. Note that more efficient versions exist. Sieve of Sundaram, sieve of Atkin, and various wheel sieves. These are the mathematicians, and they have discovered, or they have given the concept of the primes and GCDs in detail.